So we know the rule for the integral of 1 over x dx gives us natural log of the absolute value of x plus c. We're going to do some more complicated integrals, and they're going to involve u substitutions and a couple other methods, where the result is going to be a natural log function. So let's start with an easy one. Now there's two ways I can do this problem, and I'll get the same answer either way. What does that 1 over 2x mean? What do we normally do with those numbers?
Take the 2x.
We'll bring the 1/2 out front of the problem, right?
Sure.
That's what you've been doing with those u substitutions. We've been bringing the fractions out front. So when I do it this way, there's no u substitution involved. I just see the integral of 1 over x will be the natural log of x. So we get 1/2 natural log of x plus c. But I could have done this problem with a u substitution. Now this is a pretty simple u substitution. The reason it would make it a composite function is that if our outside function would normally be 1 over x, this is 1 over something other than x. So my inside function is 2x. So we can let u equal 2x, then du equals 2dx. And du over 2 will be my dx. So this becomes the integral of 1 over u times du over 2, which will give me a 1/2 out front from the du over 2. The integral of 1 over u is natural log of u. When we back substitute, I'm going to replace that u with a 2x. Now that doesn't look like the answer we just got, does it?
Excuse me. No.
But if I expand my log here, I can say that 1/2 natural log of 2x is the same thing as 1/2 natural log of 2 plus 1/2 natural log of x. Correct? Right? Multiplication inside of a log argument turns into addition of multiple log terms. And what is 1/2 natural log of 2? It's not 1, but it's a number, right? I think somebody's checking it for me. It's just a number, right?
I guess.
So wouldn't that make it a constant? Which would make it technically part of my plus c. Right? So if I have a constant plus a constant, I can just say that's another constant and call it c. So this really is equivalent to 1/2 natural log of absolute value of x plus c, which is the answer we got doing it the other way.
So both answers work.
All right, let's try something slightly more complicated. The integral of 1 over 4x minus 1 dx. So when I look at this problem, I go, I don't know that antiderivative straight off the bat. And I don't see a u substitution that's going to cancel with something, but it's 1 over something. And 1 over something makes me think natural log. So we're going to do a u substitution for the denominator. And we'll let u be 4x minus 1. Then du is 4dx. Divide both sides by 4. And I'll get du over 4 is my dx. So this turns into the integral of 1 over u times du over 4. So I can bring that 1/4 out front. Then we're going to get natural log of u, but I'm going to back substitute my 4x minus 1 in there and put a plus c. Evaluate the integral from 0 to 3 of x over x squared plus 1 dx. So this isn't something I can do off the top of my head. I need a u substitution. What should we pick for u?
X squared.
We're going to pick u equals x squared plus 1. Then my du would be 2x dx. And I see the x dx in the problem, but not the 2, right? So that's going to result in us getting a 1/2. So I'm going to rewrite this in terms of u, leaving my limits off because they would change. And it's going to be 1/2 times 1 over u du. That 1/2 came from the 2 right here that did not cancel out with the x dx.
Right.
I could write the 1/2 in front of the integral sign if I wanted to.
But that's a whole 2. How did that whole 2 become a 1/2?
Okay, this is going to give me 1/2 natural log of the absolute value of x squared plus 1. And I'm not going to put a plus c because we're going back to the definite integral here. But question, do I need the absolute value signs?
Not in this one because it's a squared function. It can't be negative.
Right, if I take x and I square it, it's going to be a positive number, and then I add 1 to it. That is always going to be positive. So it would be okay for me to leave off the absolute here. But to be safe, I always put them. Okay, so what this tells me is when I go back to my original problem here, the integral from 0 to 3 of x over x squared plus 1 dx is going to be 1/2 natural log of x squared plus 1. We're going to evaluate that going from 0 to 3. When I plug in a 3, I get 1/2 natural log of, well, 3 squared is 9 plus 1 is 10, minus 1/2 natural log. When I plug in 0, I'm going to get 1. And what is natural log of 1? It is not e. It's 0. So my answer is 1/2 natural log of 10. Remember, a log is saying for that base, what power can I raise it to and get the argument? So this log right here is saying e to the what power equals 1. E to the 0 will give me 1. And that's true of a log of any base. Any base raised to the 0 power will give you 1. All right, so when we learned the chain rule, we saw a lot of examples where we could find the u and the du just by looking at the problem. So the ones that are going to result in antiderivatives of natural log is when the numerator is the denominator, is the derivative of the denominator. So when I look at this, I see the denominator is x cubed plus x, and its derivative is 3x squared plus 1 dx. So I see my du in the problem.
Good question.
So I could rewrite that as du over u, or 1 over u times du. Okay, so this becomes the integral of 1 over u du. The antiderivative of that is natural log of absolute value of u. My u is x cubed plus x, and we need a plus c. In this instance, my argument could be negative, right? X cubed could be a negative number, and x could be a negative number, so I have to have the absolute value symbols. Okay, what about secant squared x over tangent x? Do you see it?
The derivative of
The numerator is the derivative of the denominator. So if we let u be tangent x, then du would be secant squared x dx. So this turns into the same u substitution problem we just did. It becomes the integral of 1 over u du. The antiderivative then is the natural log of u, which is tangent x, plus c.